All right, can you guys hear me okay?
Yep.
Yeah.
I think I'm crooked.
A little bit.
Well, it's all relative.
There. No, oh wait. Now I'm less crooked. Wait, no, this way. All right. All right, we're all here. I'm sharing my screen, right? Yeah.
Yes.
All right, perfect. What's today's lecture about?
Future tech robotics.
Automation.
Right, automation in manufacturing. I guess we don't want to listen to this guy talk. Any more cool robot pictures? Oh, there's some more cool robot pictures. What does automation in manufacturing mean?
Getting rid of
Like-
people.
More of a streamlined
All right,
process.
so I heard somebody say getting rid of people. Let me stop the screen share. Stop share. I should probably stop the video too. All right. And is the camera in focus?
Yes.
See how I wrote focus on the board so I had something to focus on. I was all ready to start today and then I realized there was no camera connected to this computer. So that was going to slow us down. Automation and manufacturing. Somebody said getting rid of people. All right, so if automation and manufacturing is about getting rid of people, and I'm not quite willing to stipulate that that's what it's about, but if automation and manufacturing is about getting rid of people, why would we want to get rid of people?
Probably the obvious reason is cost. You can make the cost go down.
So you want to make the cost go down.
Reduce human error.
We want to reduce error.
Maximize efficiency.
Why do you want to maximize efficiency?
Because less time is the time it takes for,
Time is money.
Cost go down, right?
yeah.
Okay, so I think we covered, is there another reason to maximize efficiency?
You can make more.
By making the cost go down? Or you want the volume to go up?
You can make the volume go up by,
All right, volume up at the same cost. Or, so it's roughly the same as make the cost go down, I think. We want to get rid of people to make the cost go down, reduce human error, increase the volume. Is there any other reason we want to get rid of people?
You have to pay people.
So we want the cost to go down.
so like they can be doing more research stuff.
Something more valuable.
Yeah.
So that's not get rid of people, that's move people. Can you guys see that through the glare spot on the thing?
Yes.
Okay. So I would say if we want to move people, it's to let them do something more valuable.
Maybe like comparative advantage, like have people do what they're best at and have the robots do what is repetitive and what they can do best.
I like what you said. I was just still busy writing down the thing I said. So it's, say it again.
So sort of like comparative advantage, having the people do what they're best at and specialized at, and having the robots do the repetitive work that they can do best.
Best. Okay. Off the top of your head, intuitively speaking, what do you think the robots are good at doing?
The same thing over and over again.
repetitive tasks.
Really heavy stuff.
Moving things fast but with like precision.
Heavy, fast,
Things that are hazardous to humans.
hazardous. Oop, I didn't mean to group those together. Sorry, I just want to make another column.
So, but for this though, are you talking more of like fully automated robots or like drones? Like,
Oh, totally different question. Totally different question. And maybe I should have started with that question. I often start with that question when I do a lecture like this. The first thing, if there's you remember we talked about standards committees, we talked about the ISO, and I think we talked about ASME and ASTM and those things. So ASME, a year ago, 2 years ago, I think it was 2 years ago, started to form a standards committee about robots. So is it amazing to you that we started to form a standards committee about 2 years ago about robots? It's actually kind of amazing to me. And I've sat on standards committees. The first question we were asked to answer in the robot standards committee is, what is a robot? What is a robot? Let's take that step back.
a Roomba's a robot.
I don't want examples of robots. There's lots of examples of robots.
Oh, okay.
Make something a
Something
robot.
that's programmed to do something.
So it's programmed to do something. So our CNC machine tools are robots by that definition.
I think probably adding on to that definition, something that like has sensors and can change and monitor itself.
Something that has sensors and can adjust its behavior or its actions or its programming based on inputs from those sensors. So my CNC machine is still a robot if it's programmed correctly.
It's autonomous.
It's autonomous. My CNC machine is still a robot by that definition.
Well,
I don't think it needs to be autonomous.
Wouldn't autonomous mean you don't need human input to run it?
You don't need human input to run a CNC machine.
Yeah, that's true.
Once it's started, and all robotic systems need to get started by somebody. I actually, depending on how you want to define it, a CNC machine can totally be defined as a robot. The word robot comes from a Czechoslovakian playwright. And he meant android type robots that had been programmed to do work for humans so that the humans didn't have to do it. One very general definition is a machine that can do the work of a human for a robot. Typically in industrial robotics, you know one when you see one. Right, we've all seen those arms that move around, right, and pick stuff up and put stuff down and all that stuff. Those are robots. I don't know about you, but I now do not receive phone calls on my iPhone unless you're on a list of like 18 people. Everything else goes straight to voicemail because there's so many robo-dialers that are trying to get me. I don't know what they're trying to do. Some of the robo-dialers are really good, by the way. There's one called himself Jason. And I was like 3 calls in before I realized Jason was not a person. So is a robo-dialer a robot?
It doesn't have a physical machine.
Does a
It's
robot
more
have a
like-
physical machine?
No, not necessarily.
I would say, yeah. I would categorize not having a physical machine as like an AI more of.
Isn't an AI a robot?
A robot has to be capable of interacting with its physical environment.
Has to be capable of interacting with its physical environment.
Well, then a robo-dialer is still a robot then.
I was going to go there too.
It's an
So-
annoying robot, but it's a robot.
So I think we should avoid the word robot in general. I mean, we could certainly debate this. And as far as I know, the committee has not yet decided on the definition for a robot. And if it's a standard written by a committee, that means it could change in 5 years also. So they could redefine it 5 years from now. We use robots so often in daily speech, and it doesn't necessarily mean what we need it to mean. But if we talk about manufacturing automation, then we mean something very specific, right? So manufacturing, we know what it is. It's making stuff with the intent of selling it. So manufacturing automation is making any part of the process of making stuff with the intent of selling it happen by itself, any sub-segment of that. And so that can include things like using pick and place robots to move parts around. It can include using pick and place robots to fill up packages and then have boxing machines close the packages. And so that's all automation. And so we do the automation, I believe, if it's not to, sometimes we do it to get rid of people. And some companies do it on purpose to get rid of people because people are the problem. I disagree, but some, especially companies run by accountants, would say that people are the problem. But we often do automation to move people so that people can do what they do best and let robots or automation systems do what they do best, which is, so why don't people do repetitive tasks very well?
Because we're not designed to do repetitive tasks.
I don't know about design.
But like, we're just not good at it. Like, we're good at it, but
Why
we
are
can't. We're not
I
the
agree we're not
best.
good at it. Why are we not good at it?
We make mistakes.
We make
Their
mistakes,
focus.
but we don't inherently make mistakes. Why do we make mistakes when we do repetitive tasks?
Because
Because
they're
we
boring.
zone out.
We zone out, as my daughter would tell me whenever she's working on her homework, I'm bored. I said, well, go work on your homework. And she says, but my homework is boring, right? If we get bored, and repetitive tasks will make us be bored very quickly, we have the chance of making a mistake. Now, heavy is obvious. We don't want to do heavy work, and we don't want our workers to do heavy work because, oh, they might get hurt. And when your workers get hurt, that has a lot of cost, especially if they got hurt doing something that you could have prevented them from needing to do. That is even more cost. Sometimes we can get robots to do it faster than us, or automation system, and certainly hazardous. The reason we don't want hazard, and actually you could group heavy as just one of the hazards. So heavy lifting is an ergonomic hazard, for example. So typically we say we want to use automation or robots to do dirty, dull, dangerous tasks. Sometimes we're using them to do tasks that we just can't possibly perform. Can't possibly perform. Like little robotic devices that they make to go inside pipelines to inspect the material of the pipeline. Sometimes you just can't get a person in there. And we typically don't call it a robotic device unless it has the sensors, unless it's reprogrammable, unless it could be configured to do different jobs, and that it has some automated decision-making on board. I still would say, though, that the RoboDialer is a robot. Let's see. All right, so we want to move people. We want to, so what's the difference between get rid of people and move people?
one of them you're driving the cost and the sale price, and the other one you're physically moving assets around internally.
Anybody else? Why would I want to get rid of people?
So you don't have to pay them?
Oh, I couldn't hear you.
So you don't have to pay them?
So you don't have to pay them.
Getting rid of people could be more monetarily, could be for monetary reasons, but moving people could be to like increase quality or something.
So profit equals value minus cost, right? If we want profit rate, we just divide by time. And we'd like to increase our profit rate. We'd always want to have a positive profit rate. So getting rid of people can make cost go down. Making cost go down can make profit rate go up, right? Oh, I'm going to say right. Moving people doesn't necessarily make cost go down, right? Because we're still paying that person. I moved them to a different job. So if I'm moving them to a different job, I need it to either make value go up or time go down. If I'm moving people, or if I'm getting rid of people, I'm only focused on cost. And I often have lost sight of value and time long term. If I'm moving people, I'm thinking about increasing value or making time go down. And this is more of a growth minded. So moving people to a new location is growth minded, and I would say that getting rid of people is fear. What do we fear when what do we fear that makes us want to get rid of people?
Running out of money.
We fear running out of money, right? We fear losing the confidence of our investors. I don't know if anybody follows the stock market or not, but when large companies announce big layoffs, they're getting rid of people. Amazingly enough, it almost always is followed by a rise in their stock value. So companies have announced to the world that they have failed to do whatever it was they planned to do, because they didn't hire those people on accident. They hired all those people on purpose. They failed to accomplish what they wanted to accomplish with all those people. They lay them off and the value of the company goes up. That's pretty counterintuitive, right?
Right.
But it goes up because the investors can see that they just saved a lot of money. The cost just went down because one of the most expensive things that companies have are their employees. So that's kind of counterintuitive. But if we can automate, take those people, move them to something that's more valuable, we can make the long-term value of the company go up. So this is why I say that automation is actually, well, there's actually a course here on campus at WPI. There's a course in the robotics program on the ethics of robotics. Has anybody taken that course? Nobody? You should take that course because you can have this kind of a discussion every day in the course. And I don't know, these kind of discussions are fun for me. But if we look at so people talk about robots on the news all the time. And when they say robot, they mean automation. Robotics and automation is what they're talking about, is what they mean. So when they say that, what are the big fears in the world about robotics and automation?
Battlestar Galactica.
Taking away jobs.
Battlestar Galactica, I love it.
Skynet.
But I don't think so. Those actually, there's probably people that do have those fears, and maybe we should have those fears, right? As the systems become more and more autonomous and AI. I have trouble with the whole premise of artificial intelligence until we can prove we have natural intelligence. But that's just my own aside. What is it that we're afraid of there? So what's the problem with drones delivering your packages?
We lose our, I guess it's like the whole like, oh, big corporations know my data, know my patterns. I'm not a person, I'm just a number. It's kind of like, okay.
There's that. I think that's more of a fear of the big data.
Unemployment.
What's the problem with self-driving tractor trailers and drones delivering packages, drones delivering
The
documents?
machines are going to
A lot
malfunction.
of people are losing their
They're
jobs.
going to hurt people.
Right. We all fear, or the fear is that color. Jobs go down, right? So we fear that jobs are going to go down. The last time I knew the statistic, there were 600,000 unfilled jobs in US manufacturing companies because they could not find qualified people to do the work. So everybody's worried about automation reducing jobs. And at that time, 600,000, and they're predicting that number could go to the millions as people like my parents retire. As the baby boomers retire, all those people leave the workforce. Many of those people work in manufacturing jobs, and they're predicting that we will lose all of that ability to do that work. Yet people are worried that robots are going to take their jobs, and they're not learning how to do this work. So if we don't, so what's going to happen to the companies that lose workers and don't have a way to get that work done?
Automation will go bankrupt.
If the companies don't automate and new people don't start learning how to do those manufacturing jobs that they don't want, that they haven't historically wanted to do for the last 20, 30 years, what's going to happen to the companies whose workers all retire, they have not automated and they can't hire new employees?
They're going to go under.
Those companies are going to go away. What's that going to do to the jobs?
That's going to decrease jobs.
Make jobs go down and down and down. If we don't do automation, then we're going to lose even more jobs than we will lose from doing the automation. What's that say about, say, to people who are learning about engineering and manufacturing today?
Good job outlook.
You get a good job prospect if you're learning how to do these kind of things. If you're learning how to train people how to do the jobs, if you're learning how to make the jobs unnecessary by doing better design and by doing automation, you've got good job prospects moving forward, as long as there are still companies to work at in the place where you want to live. Is manufacturing going to stop?
No. Until we get to the point of like Star Trek with the replicators, no.
Well, even then, somebody's going to have to make the replicators. Manufacturing is never going to stop, right? But the jobs are going to exist where the companies are that are doing the manufacturing. And so if we want companies to exist at the places where we want to live, and we want to have those jobs, then we're going to have to make sure that we figure out how to automate those companies. If it can be automated, it will be automated, whether or not it should be. Eventually, as soon as it's financially feasible to automate something, it's going to be automated. What are the first things a lot of these companies should automate, do you think? Or how would you decide if you were the manager of a company? Let's say you have a manufacturing line, you have a product line that's maybe 70% of your business, 30% job shop, let's say, what do we got? 50 employees. Let's see, 50 employees. Every fourth employee is worth about $1 million in revenue. 50 divided by 4 is what? Let's call it $15 million in revenue. So you're making $15 million a year right now with 50 employees. You're doing 70% of your product. Doesn't matter to me what you're making. About 30% is job shop work. What should you automate?
The production line.
What's
Job
that?
shop.
I heard one person say product and one person say job shop.
You could automate like transportation to and from the production lines to like the warehouse, because if you have someone like driving a forklift, they aren't really adding any value to the part. So you could automate that and
Right.
save money there.
All right, so there's sort of categories of things that we could automate. And I think it was a tough question because you don't have enough information to decide. But you can automate transportation. Of your products, or moving it from place to place. What else could you automate?
Assembly.
Assembly.
Packaging.
And so automating, so, yeah, all right, I'll talk about transportation later. Somebody don't let me forget. We'd automate assembly. What else could we automate in a system like this?
Like receiving,
So,
like input or shipping and receiving, I guess.
all right, so shipping.
Because I'm under the assumption that like there's a standard of how like semi trucks are packed with pallets and whatnot.
Having been the guy driving the forklift, loading the semi-tractor trailers in the past, unless things have changed, there's no standard.
Never mind then. Only then shipping wouldn't be receiving.
But I think there are things that happen in that area that can be automated. What else comes to mind? So in the product side of the company, in the product line side of the company, it's pretty easy to automate things like assembly, part loading. So part loading, assembly, even transportation, moving parts from one location to another within the facility. I mean, we've all seen on TV the vehicle assembly lines, right? Where you've got the chassis moving along a conveyor system. That's an example of automating transportation. The conveyor moves the chassis along the conveyor system. When it gets to a location where a job is done, somebody installs a door, say, or installs the seat on the chassis. And that is an example of automating the transportation and moving the vehicle through the process instead of having to move all the stuff to where the vehicle is being assembled. The assembly itself, if you always do the same procedure, if it's very repetitive, you can automate the assembly, you can automate the part loading of stock material into the machine, the material out of the machine, and on to the next step of the project. In shipping and receiving, a lot of time, well, we all now take for granted barcode readers, right? Barcodes and barcode readers. Our cell phone has built-in barcode readers. You can scan a product at the store and it'll tell you the whole history of the thing. I just bought coffee beans this morning, and there's an app on the bag of the coffee beans that I can scan the little thing and it'll tell me exactly where each little bean was grown. I don't know if the laser marked all the beans and if I can get a serial number, but right. So we can automate things like knowing which part goes in which box by scanning the barcodes. We can have part sorting things there. This is actually something that if you can figure out how to do this well, automate this well, you can get a job at a place like Amazon or Walmart or any of those places that move a lot of packages. What about on the job shop side of the business? What could you automate there?
You could automate or at least simplify like order creation. So
All right, so
when someone places an order, like it'll automatically
automate
create.
the system of interacting with the customer when they're placing an order. Right, so ordering. What else could I automate on the job shop side? It's going to be hard to automate things like assembly and part loading on the job shop side because it's that high mix manufacturing where you're changing setups all the time. There are people that have figured out systems to do it, but it's hard to do that.
You could
What
probably
else?
still automate transportation.
You could probably automate some of the transportation. What do we have to do on the job shop side that we don't have to do on the production side?
You have to create the manufacturing process, or you have to design the.
We have to do engineering, right? Right. So what if we could automate the engineering stuff? So you guys did your CAM assignments and things like that, right? We used the CAM software and we used it as if we were in a job shop and we were figuring out each individual part as it came along. But the people that make Esprit, the software that we're using, their goal is to automate all of the tasks that you had to do to make it so their software is really just like a printer driver. And you literally plug it in to SolidWorks, Creo, whatever solid modeling software you're using, and you click the button and maybe it says, which machine tool do you want to use? And you say, I want to use the mini mill. And it says, do you have the standard tooling in stock? Or maybe it knows, actually, Esprit can know whether or not you have the tools in stock. And it can figure out all of the different tool paths. It can be programmed to do all that stuff that we had you doing in class to learn about the process. So you can automate the toolpath creation. I met a guy from a company. They have 3 software guys. They use a spree and they generate 8 million code files a year for their CNC shop. Because they've used the automation that's built into the CAM software so that when the part file comes in, they say, oh, it's this kind of a part, and drag and drop it onto the box this makes code for that kind of a part. So you can automate a lot of that engineering stuff. In the ordering side, you can even automate the quoting. So the quote is when we figure out how much it's going to cost us to make this part, and we tell the customer how much we want them to pay for the part. You can automate that stuff. So the job shop side, at the beginning at least, when they start automating, they don't need any robots over here. But they certainly need to do automation. On the product side, there's probably going to be robots here, maybe some robots here and here. So there's a lot that goes into automation. And the first part of it is figuring out what to automate and why and how to do it, I suppose. What and why, I guess, go together, and how to do it. So if you're now management and you have to decide what to automate and why to do it, what are the questions you're going to ask? Why does management decide to automate something?
Well, you'd have to look at the cost to implement the automation.
So I want to know the cost to implement. So that's sort of the capital expense. We want to know what's the capital expense to do the automation.
And then you want to know either how much it'll end up saving you or how much value it'll add to determine your ROI.
Or profit or value. It's often very hard to argue the value side up front. Usually we come in with the savings. So the cost to implement has the capital cost, right? So that's the cost to buy the machines. Maybe it's the cost to dispose of the old equipment. We have to get new equipment in order to do this. It also has a human side, right? So our company's assets are the machine tools that we have, the intellectual property that we own, but it's also our employees. So cost savings. Anything else we want to consider if we're deciding?
Well, you could use the costs and savings to determine an ROI period, and then you could look at implementing other types of automation and determine which has the best ROI.
So return on investment. So let's, for the moment, discount the human cost. We'll get back to that. So we do our return on investment. And so often when we do our return on investment calculation, we'll make a graph. That's probably because we're engineers and engineers like graphs. And so here's cost. Here's time. if we're automating an existing process, do we already have a cost over time?
Yes.
Right. So let's say we already have a cost over time. So the total cost. So if it's this could be cost cumulative. And so our cost over time will go like that, assuming that the process is stable, right? And the cost of materials is stable and the cost of labor is stable. It'll probably go up a little bit, but the value of the dollar goes down. So we'll leave it as a straight line. What's the cost to automate? It's going to come in here somewhere. We're going to have some capital expense. And we're going to have still some cost over time to operate, right?
Right, but it should kind of like dip down as you go longer over time.
And so this is automate. This is not. So there's going to be a time over here where the cumulative cost is less than the cumulative cost over there. So this is the time to recover. All right. What about the human cost?
You need to figure out if you're going to hire additional staff.
Oh, I couldn't hear you.
You need to figure out if you're going to hire additional staff.
All right. So often we get this lower slope here. Often we get that lower slope because we reduced the amount of people required to do the process or eliminated the people needed to do the process. So a lot of the slope change comes from the labor cost changing. We can take the person and move them to a more valuable part of the process, or we could let them go. If we let them go, what are the risks that we incur at the point that we let them go?
You could lose the capability to produce, or you could lose some volume.
So
The experience.
we lose the knowledge that they have. That's the biggest problem that we faced when we let people go for these reasons. I think we got just over 5 minutes left. I want to switch topics for just a second and go through some Canvas stuff. But if you start automating systems and you're going to let people go because of it, or if you're implementing any cost savings and you intend to get the cost savings by letting people go, it's a good idea to let the people go all at once in the beginning and assure everybody that you keep that nobody else is going. If you start letting people go slowly over time, the really smart people, the people you didn't want to let go, they're going to
jump ship
your job, and they're going to go get a job somewhere else. Because remember, we got 600,000 unfilled jobs in manufacturing. If you're good at a manufacturing task, you can find a job. So, all right, that was 45 minutes of automation in manufacturing. Now, let me go back to screen share. All right, so we've got today automation manufacturing, tomorrow design of safety systems, and we're done for the term in the class. if I go to the assignments tab, when I reviewed the syllabus, so I gave you this
Showing the
optional
YouTube right
15-point
now.
quiz. I give you this optional 15-point quiz. So if you do the quiz,
Professor,
yes,
You're showing the YouTube.
I looked at the
That's cool.
quiz. It said it was 0 questions.
there's 2 of them, but let
okay.
me share the
We,
others. Where
we
the heck?
can't see the canvas. We
Yeah,
see like,
I
yeah.
know, I figured that out. Share the screen. Let me share the screen that I want to share, which is 3. Ah, I see. Oh, you saw like, oh yeah, I see the fractal nature of the sharing I was doing. Now you can see the canvas screen, right? And it's scrolling up and down.
Yes.
Outstanding. All right. So I give you this optional quiz, 15 questions, 15 points. If you want this quiz to count, if you don't want the quiz to count, don't click submit. And if you don't have a submission, then it won't count for you. And then the other quizzes will get bumped in the value. I noticed there was 15 points missing in the quiz category, so I gave you guys this quiz here. Is due today. It has 0 questions. I've already filled in the grades in the grade book of 15 points. So you don't have to do this quiz. You got those points. But the optional one there is for the people that feel gypped because I didn't give you enough quizzes. You can do that. If you want it to count towards your grade, submit it. If you don't want it to count towards your grade, don't submit. CAM assignments there. Most people, I think there's a couple of people that had resubmitted that CAM assignment that still haven't been graded. I think I've graded all the resubmissions for the week 1 and week 2 quizzes. Roughness power, all of those got graded. There were a few of you that had made the assumption somehow that the higher feed rate, which is the one that took the more power, had the smallest chip. And it's the opposite. The one with the lowest feed rate has the smallest chip. So I took up a couple points on a couple of lab reports for having that mixed up. And then group project 2, which is the one you guys actually are worried about. I put links to the 2 YouTube videos from when we talked about it. I gave you a bill of materials with pricing on it so that you don't have to look up those prices. So all we need to do is figure out the machine tools you want to do and the I guess it works out to be the parts per year you're going to make, right?
Is it possible for the description column to be wider because it's like cut off?
I suppose. Huh. Edit. No. But I don't think you need it to be wider. Part name, so base, that's stock material for the base, stock material for the Y block, the cylinder, piston. This one does not have the burner on it, but just leave that out.
All that we really need from that is that total price, right? Because that's price per engine we make.
Exactly. This table is based on this. I can't make it wider because that's a screenshot of the table, not the actual table. To answer your
Okay.
Yeah. This is based on the costs that we pay to buy the stuff.
Our group already went and got the cost of the stock and divided it by the number of engines we were making. Should we take this data or can we use our data?
You can use yours. You already did it.
And just to make sure, we're allowed to use the facilities costs.
Oh, I can't hear you.
The facilities costs that we discussed in class, can we use those?
Yeah, that's what I intended for you to use so that you wouldn't all have to go figure that out.
Okay.
And I think, so the only thing left is the final exam. It's worth 5 points. And we can review that tomorrow to see if there's any questions. And that'll be turned on tomorrow when we're done with class.
Well, we have the Esprit code so as we can know the tool we're gonna use on the group project too.
I will. Yep, I will add that right now. Actually, what I'll do is I'll have somebody put together a tool list and we'll add that below on the assignment page. We'll get that this afternoon early. You needed the tool list, right?
Yes.
Yeah, I'll get Ian to print out the tool list for us. Good question. Does the final have unlimited attempts? The final will have 2 attempts. If you had a problem with the final and you need another attempt because something went wrong, let me know and I can turn it back on. But the idea in the final is just 5 points. But the idea is to see if you learn something at the final exam, not to give you the chance to learn it while you're doing the exam. And how about the optional quiz? Yes, it has unlimited attempts, but if you do the quiz, it's going to count. I should go check the assignment to make sure that it has unlimited attempts, though. There. Now it has unlimited attempts. Okay, then. I guess I'll see you guys tomorrow.